Alrighty guys, let's take a look at this problem involving Heather, a skilled trampoline jumper. So it says Heather has a mass of 80 kilograms and she's a skilled trampoline jumper. Imagine that the springs of the trampoline stretch a distance of 1.8 meters and assume the spring constant of the trampoline is 4,750 newtons per meter. So let's just go ahead and label all the things that it told us. So this is K because it's newtons per meter and it's talking about the spring constant. The stretch of the trampoline is going to be our X value, how far that spring is stretching, and then 80 kilograms is our mass for Heather. So if we were to draw a quick picture here, it says when the springs are stretched, it would look like this is my trampoline, and the springs being stretched probably looks something like this. Again, not the best picture, but you can get the idea of what is happening here. So when the springs are stretched, we're going to assume that the trampoline's height is 0. So there's not going to be any GPE at this point. We're also going to assume, since it doesn't mention anything about air resistance or friction, that there's no thermal as well. It tells us that when it is stretched, that she is launched from rest. So rest meaning that our initial velocity is just 0. If the initial velocity is 0, then our kinetic energy is 0. Therefore, all the energy in the beginning should be EPE. So let's go ahead and figure out what EPE is. We know that EPE, elastic potential energy, is equal to 1/2 kx squared. We said that for this problem, K is the spring constant, and our spring constant is 4,750. And then X is the distance stretched, and the X value for this problem is 1.8 meters. So all we need to do is take these and plug it into our equation. Doing so, we get EPE is equal to 1/2 K, which we said was 4,750, and then times X 1.8 squared. If we evaluate this, we should get an elastic potential energy of 7,695 joules. Go ahead and take that and plug that into our answer up above, 7,695. Now that we have that, we can move on to the next part. The next part asks us for the apex. Well, we know at the apex that our velocity is 0 because we're not moving at the apex, so this is still 0. Again, no mention of air resistance or friction, so our thermal is 0. At the apex, we're no longer on the trampoline, which means that our elastic potential energy should be 0 because our springs are no longer stretched. Therefore, all of our total energy in the beginning came from EPE, and we know that we can't create or destroy total energy, so all of this energy is just going to go down to GPE. So our GPE at the apex should be 7,695 joules. Again, the reason for that is that in the beginning, our total energy is 7,695, and at the end, our total energy should also be 7,695. Since there's no velocity, and there's no springs being stretched, and no air resistance, all three of these things are 0. Now, it says to assume somebody has moved the trampoline when Heather is at her apex. What is the velocity before she hits the ground? So in order to figure that out, basically what it's saying is that we're going to come back to the starting point, but there's no trampoline there. So all of this GPE energy is going to be transferred into kinetic energy. So let's go ahead and solve for this. We know that kinetic energy is equal to 1/2 mv squared. And if we want to solve for velocity, let's go ahead and get velocity by itself first. To do that, we're going to multiply by 2 and divide by m. So we get 2 times the kinetic energy divided by m is equal to v squared. In order to solve for v, we're going to have to square root both sides. So we find out that v should be equal to the square root of 2 times kinetic energy divided by mass. So if I plug that into my equation, I can take all my numbers. 2 times the kinetic energy, which we said was 7,695, divided by her mass, which her mass is 0 is 80 kilograms. And then we just have to solve for this. If we evaluate it in our calculator, we should end up with a velocity of 13.87 meters per second. All right, now that we have the velocity, we want to figure out how high she actually went from that trampoline. So let's go ahead and do that. In order to figure out the height, we're going to need GPE. And we know that GPE is equal to mass times gravity times height. If we're solving for the height, we're just going to divide by mg, therefore giving us GPE. GPE divided by mg is equal to our height. So let's go ahead and plug those numbers in. The GPE at the apex is 7,695. The mass is still 80. Gravity is 9.8 because we're on Earth. And then we just solve for h. Evaluating it, we should get that h, or the maximum height she achieves, is equal to 9.82 meters.